Hi guys, good morning. So my name is Ephraim de la Serna. I'm from Integrated Maritime. So we're going to continue the lecture regarding air compressors. So again, we're Integrated Maritime is a practical assessment center and technical solution situated in Cebu. We're just very near inside Marina. We're just 10 meters away from the doorstep of the STCW office here in Marina. So uh, the topic today is about air compressors. First, we're going to have a lecture first on air compressors because on episode 2 we talked about the emergency generator. So this is just a part discussion, familiarization with lectures about air compressors. Okay, let's begin. So eventually it's mapped from the Kongsberg manual and all manuals regarding what I have experienced on board. So I just compiled it. Some came from we would like to thank also Marine Insight, Maritime Hub, and all the websites. Eventually, everybody in Google. So last also. So an air compressor is a device that converts power, usually from electric motor, a diesel engine, or a gasoline engine, into kinetic energy by compressing or pressurizing air, which is on command and can be released in a quick burst. So basically, that's an air compressor. So uh, So the working principles and operational guidelines. Use of compressed air for ships. The main aim of a compressor, as the name suggests, is to compress air or any fluid. Meaning when we're talking about any fluid, because there are compressors which has oil and water on it. I mean oil and air which are mixed and eventually it's separated in order to reduce its volume. Some of the main applications of the compressors on board is the main air compressor, the deck air compressor, the AC compressor. So that's the fluid, the freon. Eventually, it's not freon. It's a refrigerant. Freon came from DuPont. It's a brand name. Freon is it's always remember that freon is not uh it's not a brand. It's not a name. It's a brand. It's not it's a brand name. It's not um it's called refrigerants. Okay, and in refrigerations compressors. Okay. So uses of compressed air on board. On board merchant ships, compressed air is used or for gives used or for have been mentioned below for automations, control for main engines, auxiliary engines. For starting the main engine, auxiliary engines, emergency generators, emergency fire pumps, for heaving lifeboats, and the use of an air motor, for pressurizing hydrophores, for domestic freshwaters, sanitary, so almost everything. For use in sewage plants for conducting aerobic sewage breakdowns, used for horns in ships' whistles, used in pneumatic tools like pneumatic grinders, chisels, drills, and spanners, used in painting operations, uh, for general cleaning, soot blowing of boilers, used in pneumatic pumps for oil transfers, and used for general service, and a lot more. Okay, I just named almost every part of the ship. So typical compressors on board. There are three typical compressors on board. One is the main air compressor, which supplies high pressure air for starting main and auxiliary machineries, and the other one is a package type compressor, which supplies low pressure for consumption of equipment and other auxiliaries. Mostly package type compressors are situated on deck. Yeah, because and mostly some on ships or it depends on what the construction of the ship is, but mostly package type compressors are being used for deck machineries and also deck equipment. We have also an emergency air compressor here. We have an emergency air compressor which will be tackling on that specific topic. Supplies high pressure for starting auxiliaries for electrical power plants. And so what's the specifications of air compressors? Number one, it should be in the compression stages, meaning how many stages does the compressor have. The cooling or method or Either it may be air, water, or oil. The drive method, the motor, the engine, steam, and others. For lubrication, it may be oil or oil free, meaning if it's oil free, we'll be talking about the emergency generator. And the five is a package or it's custom built, meaning you have to ask a manufacturer to custom build the compressor for your specific needs. Next, the required pressures on board. So you have a 25 to 30 bar, a 4.4 to 7, 1.5 to 2. First is the 25 bar is boilers, soot blowing, starting of main and auxiliary engines. The main and auxiliary engine starting air supply is to be monitored carefully for excess oil and water. So eventually, we will be discussing that one on the preparation for departure, where you have to again drain excess oil and water since even though there's a water separator, but once it's stored in a tank, moisture will be there. So you have to drain water from the we have specific instructions for that on especially with our cadets. So fitted with cylinders, lubrication, then particular attention. The cylinder oil feed is required. Moisture traps, drain valves are to be blown down at regular intervals. I had an experience with this one moisture traps where we there is a system on board where there is an automatic draining of auto traps. They call that auto traps on board. But eventually you have to maintain it because eventually it will not it won't sometimes you have to do it manually because don't rely on too much automation. So that's the 25 to 30 bar high pressure. Next is the 4 to 7 bars. So we're talking about service air, whistle air, pneumatic tools, lifeboat, pilot ladders, compressed air equipment which supplies low pressure air for the control and instrumentations must be monitored constantly for moisture, which is wet and common. Very important. So some they have a filter dryer for this one also. Uh, we filter dry the especially with the pneumatic tools and the lifeboat tools. So we have um what do you call this water separator. So it just separates the liquid so that especially with the lifeboats because when they call that the fibra on board. Uh, when that will be damaged, it will eventually stuck. Then you have a very low pressure um, pressure which is used for instrumentation control compressed air, which is typically treated and dried to ensure the full functionality of critical instrumentations on board. So as you can see, this needs a dryer. Next, the types of air compressors. They have reciprocating, a rotary screw, and a rotary centrifugal. So we'll be tackling about the reciprocating mostly used on board, and we're talking about the rotary screw for the service air compressor. So let's focus on the rotary reciprocating. So let's try. Uh, so I have a video here. So I
A
just got
reciprocating compressor compresses refrigerant vapor in a cylinder using a piston.
Oh no, this is not the video. So we will just have to switch that one. But it's just the same principle. So this is a typical Spiri. It's a it's a compressor. We will discuss further because I will be talking on the operation on not on the construction, but just to give you a brief overview, it's just the same thing. It compressors. It's a reciprocating, meaning it goes up and down with a piston. It has a interstage cooler and everything. It has a filter. So this is how it really works. So air comes in here, process it there, low pressure. It goes inside to that. If we go here, so it goes inside to the low pressure. This is the bigger the piston, the lower the pressure. So once it goes inside, it goes to that specific cooler. Then it goes back to the smaller piston, making it into higher pressure. Then it goes back. Then it goes out. Typically, very simple. Okay. Just a brief overview because we'll be talking on the operations of Kongsberg. So I will just have to skip this one. You can read this one, but it's all about the performance factor. It's the suction pressure, the ratio of specific heat, the discharge pressure, the suction temperature, and the speed requirement. So you can pause it, you can read it. Eventually, we can give it to you for references just to learn about compressors. So Integrated Maritime is also doing PowerPoint presentations for schools and training centers and so this is one of my PowerPoints. So the cooling system of a core compressor is thermosiphon. The driving force of a thermosiphon derives the change in density in the cooling fluid from hot to cold sections of the system. A pressurized is a pressurized cooling system that are mostly common, meaning there's a specific pressure. Always remember that pressures for this one is it's called the damaging the not the we call that the damaging fluid. So meaning if you have a cooling water, it's much more better that air goes into water than rather water goes into air. So that's how they calculate it, because that's why we call it the damaging pressure, because like a heat exchanger where um seawater and fresh water. So with seawater you have just a typical example of a heat exchanger where the pressure, if it is the pressure the if the fluid is safer, um, rather than to be damaged. So fresh water goes into seawater. So eventually you lose fresh water, but it's much better that way rather than seawater goes into fresh water, which damages the whole components of the engine. So that's mostly pressurized system. That's the theory of engineering in pressurized systems. So the system consists of a circulating pump, a surge tank, and an accumulator. So you have static systems, sometimes used on small compressors to assist air-cooled systems. Cooling fluids functions as static heat sink and acts more. So static systems, it's just a heat sink. It's just like the principle of a laptop computer. So where the cooling fluid and a static heat sink and an air cooled. So an air cooled system uses it has this system called where you have to cool. It's just fins. Rarely it's fins. So it's just like an air cooler principle used for heat throughputs and low heat loads, cooling fins, and provide a sufficient surface for to cool the cylinder. The methods of lubrication in a compressor is the frame lubrication delivers oil to the frame, bearings, connecting rods, rod bearings, cross head shoes. Some frame lubrication systems are also supply oil to the packing and cylinders. Splash lubrication system distributes lubrication oil by splashing to the crank through the lubricant surface of the pump. Dippers may be attached to the so meaning a dipper is just like it just gets oil from when it turns, it dips oil and splashes all around the surface of the system. Pressurized lubrication, the most common type of frame lubricants is the pressurized system. So it has an oil pump with drilled passages on the crankshaft or main crankshafts, and anywhere it just distributes with oil. So it's called drilled passaging. So I will not talk about rotary compressors because I will be focusing on that one here. So I think that's it. So we'll go now to the Kongsberg simulator because I will be focusing on the operation of the Kongsberg. This is just a brief overview. You can review it uh, so that you will get a brief overview. I have lots of PowerPoints here, but the size, desk. Okay, let's just discuss this one because we will just tackle on the rotary compressor. These rotary compressors are just screw compressors. They tend to be compact and smoothly running with limited vibration, so does not require spring suspension. Many rotary screw compressors are, however, mounted using rubber vibration. This is one thing that you should check on rotary air compressors, or they call that a package type compressor, because once it starts vibrating, the belts will eventually break. To the rubber vibration isolation mats just absorbs the high frequency vibration because it's rotating at very high speeds. I have a video for that one. I got it from YouTube. Unwarranted use of ships to be avoided at all times. It's essential that any deck services are shut down when not required, meaning If don't switch on the I have experienced this one, so that's why after working with the service air compressors, you have to stop it. Okay, because sometimes on board they forgot to stop it, so it's running for 24 hours with no consumption, with no use at all. So you have to save power on board. You have also okay, alarms. All compressor alarms, shutdowns, measuring instruments are to be checked and calibrated at regular intervals and in line with the planned maintenance system requirements. So there is a planned maintenance for this one. So emergency compressors are tested to be part of the weekly safety routine. So when you're a fourth engineer, you have to check all emergency air compressors or eventually every day. If possible, you have just to roam around before you go down to the engine room. So why the ships needs air dryers? Excessive water in compressed air, either in the liquid or the vapor phase, can cause a variety of operational problems with users of compressed air, including freezing of out their lines. So I have experience where the water, because there was too much water on the pipe when we were inspecting ships before. Uh, we have to drain the water inside because especially when I was on a car carrier, um, there is a drain line there where you have to drain the air line because eventually when you're traveling from hot to cold climates, moisture is there. It traps in the system, and eventually before starting, you have to drain the water. It destroys pneumatic tools. That's one of the reasons. Malfunctions of pneumatic process controls, or you have water cannot be compressed. We all know that pneumatic process controls are very, very sensitive, so you need to dry air, the fouling in the processes and products, and more. And there's a lot more effects without drying air, so very important also. And that's it. So we will be talking about this one. So now we'll be shifting to this one. Yesterday, we to recap the system of Kongsberg, we talk about. So now we have an initial condition here where we connected the emergency generator already. It's already been running. It's connected to the emergency bus bar. We have already all the emergency switchboards and everything. So we're going to connect now with the start air system. That's why this is a semi-start air system because we'll be talking about the emergency air compressor. So um, on this start air system, we have three compressors, uh, two main air two main air compressors for redundancy requirement for SOLAS, and also with IACS and all classification societies. It's called redundancy of systems. So when a failure of one, it should not impale the operation of the vessel. So, but an emergency compressor is only one. So, but in this system, you have both. You have two possible ways to charge the start air emergency reservoir. So as you can see, we have a low level pressure here on the start air emergency. So there are two ways to charge this one. It's a hand pump. So let's start running now. So it will take a long time, but we will be discussing further on the start air system. So what say, for the meantime, I will just discuss on the emergency starting air compressor. So I you can charge that one. You have to open this valve here, and as you can see, pressure is rising. I have to switch a little and increase the timer to 3.0. So I have a higher time. So I just shifted the timer here so it can speed up the process a little. So now I'm charging with a hand pump. You can use that one, or you can use the emergency air compressor. Now on Kongsberg, um, in integrated maritime, we configure this one that you can attach this one because one key element of um our working on something automation. So one key element that we are training students is to be very very familiar with the 3D animations in Kongsberg. Why? Piping diagrams are there. Block diagrams, schematic diagrams is there, but once you go on board, we prepare students to use this one. So I'm switching now to engine room VR view. Okay, I have two screens here. I will just switch so I can. Okay, now I'm here. So as you can see, it's quite dim inside. So we have reconfigured the system so that students cannot touch here and eventually use the 3D directory going to the start air. So as you can see, we have typical setup of a starting air system. So as you can see here, there's the view. So you have an emergency air compressor here. You have a starting air compressor and another starting air compressor. So the air compressors will eventually trip if you have a discharge air temperature of less than 100, of more than 110 degrees Celsius. The lube oil pressure will also trip if you have a lower pressure of 0.75 bars on the lube oil. So, okay, I'm just reading the book for the Kongsberg. So, the emergency air compressor is air cooled, meaning this one here. So, as you can see, that's the purpose of the fin. So, one thing you should remember when you go on board, don't paint it. You just clean it, clean and clean and clean, because the thicker the paint, it will lose its heat. The transfer, it will lose its cooling capabilities, because you're instead of maybe you're making it nice, but eventually you're destroying the specific compressor by making it thicker. Eventually it looks nice, but it will certainly not good. It's not good for things to be painted. That's why mm, it's much better if you make it, just clean it, just clean it, just don't overpaint it too much. If you wanted to paint it, just go for a thinner paint. Okay, so we can switch from this one from master. So um, I'll check first. Okay, the long periods out of operation. So the emergency hand pump is not here on the 3D animation, but the starting air compressor is here. So I have also a view for the walkthrough, but let's start with the VR view since we are talking about ladderized systems on training specifics. So the first thing to do, so let's check first what's in the component you have. Um, you have to be very familiar with the piping diagram first here. So as you can see here, this is a specific piping diagram, and you have an emergency air compressor here. You have a starting air compressor there, air compressor here. You have a starting air reservoir. One thing, especially when you're a student, is that you have to be you know how to read the diagram, but when you go out in an engine room, it should be yeah, with one look, you know how a starting air receiver looks like and an emergency receiver looks like. So this is the emergency air compressor. It's smaller than the starting air receiver. Starting air receivers are very, very big. It's around probably 2 meters or 3 meters longer, and half 1.5 or 2 meters wide. So it's really, really big. This may not seem so. Persons probably will just stand up around here if we measure that one. So I'm trying to ask some of my friends in on ships to send pictures of an actual picture of a start air receiver, so you can see the clearer picture. So you have valves here, you have also gauge here. So we have also this in on this system. When we configure, we reconfigure the system, so you have to check the start air receiver. So you as you can see now on this one, you have a very good dynamics on how to read pressures. You have a drain bottle here. So the first thing that you will do is first check first for water, because if this is so later, as you can see, there's nothing inside, because eventually if you look at the diagram here, so 0, I just drained water. So Kongsberg is really dynamic. As you can see, it's open. When it's red, meaning there's nothing. If I close it, and it closes also. Okay. So there's no water there. You have to check for water first. Then you have to line up these valves. I'm closing this one. This one is not in the 3D animation here. So trying first things first is you have to line up, check. Now, on this system, it's just an ordinary air compressor. May look very ordinary, but there are some things that you have to prepare first. First is you have to drain this one. These are called intercoolers. You have drain valves. You have to check. As you can see, visualization is key here. So sometimes if there will be water accumulated, you will see that there will be water there. Close it. Check this one. So that's nothing there. Those are initial startings for air compressor. So this one is air cooled, so meaning you don't need to open any fresh water. So as you can see, there is no connection for fresh water here. But later, when we start the whole main starting air compressor, you will get the whole idea how it runs. So this is the two valves that I opened. As you can see, again, open that one. If I open that one, BO3583, it opens. Okay, it's the same thing. Close that one. Open this one, and that opens. Okay, very important. Now, what I need to do is I need to put this one on line up mode. Start, open. Now I'm looking for this valve. If this is 14606, switch that one. Eventually, that's it. 14606. As you can see, you can even check on it. So this is how you work with on your onboard systems. So you have to check on the inlet valve. This is the valve description number, very important. These are called plates, and eventually don't paint it on board. Yeah, some engineers paint it really. I have seen a lot. That's why when I was working on board, I remove it, put some masking tape on it, paint it, clean it, so that you as cadets can memorize it. Usually my cadets on board, this is what they do. Eventually with familiarization, I let them line up the piping diagrams and and clean the plates so that they will have a better picture of where to trace. Okay, now we have it's ready. It's open already. So I will not yet open the outlet for the generators, so you can switch here. This is the panel for the emergency compressor. As you can see, it's very dynamic. This is also in eWatch, like putting from local to remote and everything. So what I do now is I put that on local. If there is an alarm, so as you can see, there is power here, and this one has no power, and that one has no power. So I will put it on local first, then I start the simulator. So the only way that you will see it is that this one has, again, I will state it again because mostly of my cadets don't see this one. When this is an indicator that it has power on it. So if this one has no power, the breaker is off. Okay, meaning it's not yet connected to, since it's still running on emergency modes. So if I start that one, so eventually you have a very high current at the start because it's called unloading. So meaning the compressor will first unload because it's because of high torque. So they have to run at, eventually when it starts, it has a solenoid valve which opens first for current. So that's why the current of the emergency air compressor just flick to more than their specific it's called as starter panels. So it delays the current rise in the system. So as you can see, it's not stable at 40. And if you look at it here, now if you have finished that one, you check here. So eventually it's rising. Okay, so let's check on the diagram. So this is just for the monitoring panel. What we do with Kongsberg is that we don't cadets can't open these valves really. We restrict that one so that they will have a better view of how to operate it on a local mode, because eventually on board you have to go out in an engine room and open those specific valves. How do you do that one? You go to the VR view, and this is maximizing the VR view of Kongsberg. Okay, so we have 15.88 already. It's now rising. So it's just the same thing on starting air compressors on the later phases, because we're starting from cold ships and we're explaining about emergency generators. So emergency generators are very important on board. Sometimes it's near the emergency air compressors. You have, if you're the fourth engineer, you have to, as much as possible, if you can do it daily, just look at the pressure. Just look at the pressure here. Take routines on it, so that you will not have problems. Drain water, but every Saturdays or 3 days, we charge this emergency air compressor, drain water from it. We ensure that there is no leakage test. There is a monthly plan. Follow your PMS. It's all there. Okay. So 19.93. You can open this valve. So it's still low pressure. Alright. Now, where is this valve located? It's just here. Let's just check that. So you have a relief valve also. Uh, Wait. This is the valve, the outlet valve. So you can see this one. That's one. See, it's open. That's 14662. You just hover over the valve and you get the 14462. Okay. So check that one, open. Then, so you can see here. Now I'm trying to open that one with the generators, and open that one and open this one. But I'll be starting with generator number 1 first. So I got the pressure, because the next phase I'll be starting the emergency generator. That's episode 4 of this lecture. So again, what are the, to sum it up, emergency generators are used on board for emergency starting of main auxiliaries. It's a small compressor, but it can supply 30 bars of pressure for starting generators. It has a power. It's connected to the emergency switchboard. As you can see here, this is just a recap. You have to drain first before starting, and eventually when that is filled, you have to, as you can see, the Z stands for contaminants. So it's rising because it's charging. Okay, so when everything is set, on the full mission simulator, you have the panel control. You go to the pump control system, and as you can see, the emergency air compressor. So I'll just go back again. You go to the panel directory and go to the power chief 102. This is the pump control on the full mission simulator. This is just the same thing, but what you need to do is you just press auto, and yet it cannot. Why is it blinking? If you get this alarm, meaning you can click these specific numbers, it will go to that specific module. Again, you have to click that one, and as you can see, it's still local. So I'm not clicking here because that's a piping diagram. That's only for guidance and observatory. I go to the panel directory, go to the VR view. Oh, no, I mean I have it here. So I switch that one on, put that on remote, go back to the panel directory, and what I'm using is just an alt tab. So Kongsberg can really configure into 4 screens. If you know how to use the alt tab system in Windows, I can configure this one into 4 screens, so switching of faster switching of modules. So I just alt tab it and go to pump control, and again I click that one. Eventually the emergency compressor is now in automatic mode. So I hope we learned something today about emergency air compressors. Summing it up, always remember that emergency compressors should be checked and routinely be. You should have a routine for this one because this is one of the key essential things. It's very hard when you got a blackout and you don't have an emergency compressor on 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 standby. So especially when you're on very if you have a very hectic schedule on port, you don't want a blackout, and yet your compressors are has no pressure on it. Okay, so thank you very much for listening. This is episode 3 regarding emergency air compressors. I just briefly talked about air compressors, but later we will try to expand it a little. Uh, Thank you very much for listening, and thank you for subscription. It's we're currently growing. We have already 8 subscribers. So if you wanted more videos, please subscribe because we wanted as much as possible to spread all over the Philippines regarding how to discuss the VR view. And eventually, where somebody just requested, sir, baka pwedeng Bisayain na or Tagalogin na yan. Yeah, but we're looking for bigger pictures, more comments. If you wanted comments on that one, please do not hesitate. If I have missed something, please comment on. We are very open for constructive criticism and how to maximize the program. We're still building it, and yet we had already have an audience. And once again, thank you very much for listening. And this is Integrated Maritime. We're situated at Cebu. Our company is primarily in Cebu. We're just 10 meters away from the doorstep of the STCW office in Kimunda building. So I would like to thank Kongsberg. I'd like to thank Mastex or Ray Tanutanud for supporting the supporting Integrated Maritime. All the schools that we have helped. Um, I would like to say also to my friends in Malaysia, or because they requested the reason why it's English because it's we're requesting it to become English because they are listening in Malaysia also. So thank you very much and have a great day.